Okay, today I would like to show you how to use a Rhino Compute service through Python library. Rhino Compute service is a work-in-progress service which enables you to access to the Rhino geometry functions through REST APIs, meaning that you can access from anywhere you can imagine through a network, which is pretty exciting, thinking the possibility what it can do with this service. Well, this service is still in experimental state, so there is a chance it's gonna be discontinued at some point or be licensed that you have to pay some fee to use this. But for now, it's a work in progress. If you have a license, if you have a Rhino license, then you can use it as an experiment. So I'll show you how you can do that. Okay. First, so since today I'm gonna use the Python to use this Rhino Compute service, I'm gonna use a PyCharm IDE. But you can use any other editor you like. One thing to mention is that the Python version which the library supports is 2.7 or 3.7, I think. So I'm gonna go with the Python 3.7 for this example. So I made a sample project in Python using Python 3.7 interpreter. Okay, and let's start writing some code to use this compute Rhino3d. Now, the thing I have to do is to set up the interpreter to have a necessary library or modules installed. So go to the settings of your PyCharm if you're using PyCharm, and in the project interpreter, I have clicked this use conda package manager and click this add button. Search for Rhino. It will show you several libraries that I need. First, I'm gonna install this Rhino3d. This is a Python wrapper for OpenNerves library, which you can access, which you can use it to write and read Rhino 3DM files or make basic nerves geometry based on Rhino. And I am also going to install this one, compute Rhino3d. This is the one that I'm gonna use to call the REST API to access to the Rhino rich geometrical functions, which is on the server. Now, currently, the compute Rhino service needs a server which have Rhino work in progress version install, which is this one. So it could be either on your computer using this one, or it could also be on remote server. And right now, currently, McNeel is installed. McNeel has several servers installed in installing this Rhino WIP on AWS, and you can access through this Python library right now. So let's try to use that for this example. Okay, now I have installed the modules. Let's make a new Python script. I'm gonna call this a compute Rhino 3D example. Now first thing, I'm gonna try to use the Rhino 3DM first, so that to show you can access to a Rhino openers functions like writing 3DM files or reading 3DM files, making basic geometries using this library. And first I'm imported the Rhino 3DM, then I'm gonna also import the random module so that I can deal with the randoms. And now let's create some random points in the scene, so to just show you how you can create geometries as a Rhino file. Okay, let's make 20 points and pt equal, gonna call Rhino 3DM point 3d. Gonna use the random uniform to have the x and y size randomly plotted. Okay, like minus 10 to 10. And for the z value, I'm gonna make it 0. Now this PT will be a point geometry at this point. And if I print this and see the results, I have these point geometry here. Now in order to save this into a 3DM files, first I have to make an instance for 5-3DM like you do in Rhino Common. So model equal Rhino 3DM dot file 3DM. Okay, then let's add this point to this model objects add point. Right. Now the points has been saved to the object table of this model 3DM file, which is still temporarily, so I need to save it to as a file somewhere. So I'm gonna save it to the same directly here. So what I should do is to call the write function, which model has file 3DM file has, and set the name like sample.3dm, or I should say points.3dm. Okay, and I should also set the version for the file. Now I have the Rhino 6, but if you only have Rhino 5 or Rhino 4, you can say something like this to specify the version you want to save with. Now let's call this run. Now you can see some geometry, some files has been created here. Let's see, and then Explorer, and as you can see, this has a 3DM file. If I open it with the Rhino 6, I can see that several 20 points has been created on randomly plotted on the plane, XY plane. Cool. Now this is how you can use Python to create a 3DM file. You can basically create like basic geometries using the Rhino 3DM modules, but it's kind of limited in terms of functions, since it doesn't have some rich functions which Rhino have, like booleans, intersections, loft, something like those kind of rich geometrical modeling functions. So in order to access that, right now you this Rhino 3DM cannot be used for it. So this is where it comes to use this Rhino compute service. By using this library, you can access to a pretty rich geometrical functions, which offers here you can see the list of the functions that is offering here. Now let's see how I can use this thing. And first of all, the point itself is not enough for the bases, so I'm gonna make a circle out of this point. So I'll make a circle equal Rhino 3dm dot circle. This is still a primitive basic geometry, so I can just use the Rhino 3dm. And for the radius, I'm gonna call a random uniform from 1 to something like 4. Okay, and add this to the model, add circle. Okay, let's see if the circle has been saved to the 3DM file. Maybe I should rename this to circle as well. Run it. Now I have this new file, circle. Yeah, now I have both points and circle. Now the next thing I would like to do is to combine or Boolean union all these curves. So in Rhino, I think what you do is Boolean curve or Boolean. I'm not sure if you can use Boolean union for the curves. Maybe not. Nope. So Boolean curve Boolean, and select all those curves. And what I want to have is like add all these curves together to have a unified curve. Now, in order to do this programmatically, the thing is that this Rhino 3DM doesn't have a function for Boolean. If you go to the API document for the Rhino 3DM and search for the Boolean, it doesn't really show the curve Boolean functions here. So it cannot be done using this one. But if you go to the compute Rhino3d API document and search for Boolean, it does seem to have some Boolean function here on the curve. So let's see. If I search for Boolean, there is a function called compute Rhino3d.curve.create Boolean, which shows that calculates the Boolean union of two or more close. So this is exactly the function that I want to use, and it's only available in this compute Rhino3d. So let's try to use this next. So first you need to import the compute Rhino 3D 3D modules. The next thing you should do is to make a access token or authentication token in order to access the server. Since it's going to access to a remote server at this point, you need to have a authentication token, so that like to limit the access, that in order to reduce the in order to secure the server, so that some people wouldn't be able to access the server like maliciously. Now in order to set up the token, you first need to get the token from the Rhino, the McNeel page. So go to this go to the first go to https www.rhino3d.com compute, and after this add login to the address, and it will lead you to a page where you can generate your authentication code based on your McNeel registration information. So you do need to have a account on McNeel. It might work with the trial version, but still I think you need to have some sort of license in order to generate this thing. Now if you get this, copy this. Now every time you log in, the authentication token will change, so I don't think you can use the same thing as I'm showing right now. And go back to the Python and type auth token, or I also need to import one more module, compute.rhino3d.util. Now in this util there is a property called auth token, which you can then enter the auth token that you have just copied. Alright, now this is ready, and now I think I'll be able to connect to a Compute Rhino server, which is on the AWS McNeel is installing. So let's call the function to see if I really get the results. Now let's go back to the API document and see what the parameter is for this function. So I need to first import the compute Rhino3d curve module. So let's go back here and import compute Rhino3d.curve. And second, I need to have a list of curves in order to calculate the Boolean. And for this multiple, I don't think I need to set up for this example, so I'm gonna set it to default, which is false. And as a result, you'll get this list of curves. Okay, so first I need to have a list of curves in order to feed in to this function. So let's make a list, empty list called curves, and since the circle is not curve as a geometrical type, so first I'm gonna need to convert this circle to NURBS curve, then append this curve into a curve like this. Now all the curves has been added on to this curves list. The next thing I would like to do is to now call this compute Rhino3d curve create Boolean. So compute Rhino3d curve create Boolean union, and the input is curves. Okay, and I'm gonna make this b curves to have this result. Okay, now let's check the results by checking all the b curves, Boolean curves, and let's print this out to see if I really get the result. Okay, now let's save this, call this, see the results. And yes, I do have this, I do get this result, which is in JSON format. And I can see that this is the data, which the data property says that some weird strings, which could be explained as a binary object. So, and it doesn't really show whether it is a curve or a surface or VREP or points. It just shows data like here. And with this information, you cannot add it to a model like you did here. If you try to add this, like add curve, this V curve, I think you're gonna get errors since it is still not in Python object, but it's in JSON object. So if I play this, if I run this, yeah, I get this error because this is not in the correct format for the model.objects.addCurve to be used. So in order to convert this JSON to specific types of geometry, which Rhino 3DM can recognize, I need to call specific command, specific functions, which is called, I'm gonna call this vCurve object. And there is a specific function which is in the Rhino 3DM common object called decode. By using decode, you can convert the JSON object to a Python object of for the Rhino 3DM. And it automatically recognizes whether it is a curve, a surface, a VREP, a mesh, or something like, or others, by just using this decode. So now I have decoded the object to a Python geometry. I think I'll be able to add it to a model object table. Let's cancel all these and just have this curve added to the model. And then let's call this Boolean 2D. Okay, and run the project again, run the Python. And if I open this Boolean 2D, voila. So, yes. So the one that Rhino 3DM couldn't do, we'll be able to do using this compute.rhino3d by calling the function through the servers. It's pretty cool, isn't it? So, I mean, this is pretty much how you can use compute.rhino3d in Python. I'm gonna show you a little bit more to see to show how you can let's make it a more three-dimensional. After making a decode into a curve, since this is a curve, I can use I can extrude it to create a extruded curve extrusion. So I'm gonna call it extrusion. Rhino 3DM has a extrusion create command, and let's extrude this V curve object, and I'm gonna have to set this height, so I'm gonna set it to 5. And what else? Let's see. Go back to the Rhino 3DM API document and search for extrusion. go here, create. So for this one, yeah, there is a third parameter, which is a cap, whether you want to cap the bottom and top part. So I'm gonna set it to true. Right. Now for this one, I'm gonna add it as an extrusion. Okay, and run it again. Oops, I should have named this extrusion. Okay, let's see. And here it goes. Now, since I'm just running on pure Python, but you can also use this in other softwares like Unity or like Houdini, where it's still a 3D based software but uses meshes. So, and there is a function for compute.rhino3d which converts brep to mesh, which is not available on Rhino 3DM but only available on compute.rhino3d. So let's use that to create a mesh so that you can calculate to create the breps, but still show it on mesh based softwares, yeah, by converting vrep to meshes. Now let's do that. So in order to convert the brep to mesh, let's go to the compute.rhino3d and search for mesh. Go to the mesh, then think there's a function create from brep. Yeah, here it is. Now let's use this. Let's use this to convert the brep to mesh. So first I'm gonna import compute.rhino3d.mesh, then go back here. Now I have this Boolean here, or it's not Boolean, it's extrusion, so I still need to convert it to vrep as well. Now the thing that I need is first a brep, and first parameter is brep and second parameter is multiple, which is okay as a false. So okay, first I'm gonna cancel this and convert this extrusion to brep, which can be done by let's see how I can do this. Go back to a Rhino 3M extrusion. Let's see if there's a converting function for it. Okay, so there's a 2brep function, and the parameter says split kinky faces. Let's just say yes. So 2brep true. Now I have a brep converted from the extrusion. Now next thing I would like to do is to call this compute.rhino3d.mesh.create from brep. So let's call this compute.rhino3d mesh create from brep, and use brep as a parameter, and let's have this result inserted as mesh. Well, this is gonna be a list of meshes, so I'm gonna set it meshes. Right. Now for the meshes that I'm gonna get, let's check if I have result. As it's supposed to. Okay, I'm gonna print out the mesh one by one like this, and as similar to the curve, it should return it as a JSON. So I just run it. And here I have this JSON file. Still have like version, archive 3DM, open nerves, and data. And the data still shows in binary. So I still need to call this decode. Whenever I get a geometry out of compute Rhino, I need to call this Rhino 3D mean compute common object dot decode. So let's call this and decode the mesh and insert it into mesh object. Okay, now next thing I would like to do is to add each mesh to the model objects table by calling add mesh. Okay, and let's call this mesh.3dm, and let's run this. And as you can see, since this is pretty expensive function and it's pretty slow to get the results because it's calling one by one here, it's taking like 5 or 10 seconds here, and it might not suit for a real-time project. Like if you want to change the results in real time, it might not suit to your need, since it's calling the function to the remote server. But I got the result like this, which is pretty cool. But there is a way to speed up the calculation for this one. That is when you install the compute Rhino server on your local machine and run the local server act as a compute server, which is right now on the AWS server, which McNeel offers. And I'm gonna briefly show how you can do that to speed up the calculation. Now, if you go to this main page of Rhino Compute Service, there is a link to a compute GitHub page. Go here, and here it shows how you can build, or how you can install a compute Rhino server on your Windows machine. It does have to be a Windows machine, since Rhino work in progress version only runs in Windows, and I think it's in 64-bit. Now this example, this document or this tutorial is saying that you have to have a Windows Server 2016 computer, but actually you don't really need to have this Windows Server 2016, since I have installed on this computer, which is Windows 10, and I think it still works on Windows 7 and Windows 8 as well, as long as it's 64-bit. So I'm gonna show you how you can do that briefly. Now, the first thing first, you do need to have Rhino WIP installed on your Windows machine. So just search for Rhino WIP and install it on your computer. You do need to have a Rhino 6 license in order to install this. And after that, go to this link, get the latest build, and you see two different versions for the compute Rhino server. If you want to install the compute Rhino server on your local machine, I think the first one suits. If you want to install the compute Rhino server on the remote server like AWS, you can choose the second one, but I chose the first one. Now if you unextract it, you'll get this source folder, which is this one, and inside here, bin release, there is some exe file and other DLL files here. And go back to the GitHub README page and skip all these, since you already have a Rhino WIP installed. You can also skip this, and from here do exactly what it says. Open command exe cd to release directly in run compute, or just double click this compute.frontend.exe, and now it shows windows like this. And I think on the first, when you first install this and open this exe file, you get some errors. So what you need to do is to type in this to a command line or to a PowerShell. So what you need to do is to search for PowerShell and open as administrator and copy paste this one to here, and I think for this one as well. And I do believe that you also need to change this 80 to 8081 as well. You also need to add this one as well in order to access the backends, which is listed here. Okay. Now do that. By doing that, reopening this front end exe file, you'll see this without the errors. And if you see this without the errors, then you'll be able to access to the local compute Rhino server at this point. Let's try to check that. If you go to a 127.00.1 and port number is 8081, and let's do a version. If you see this page, it succeeded. You now have a compute Rhino server running on your local machine. And if you go to the SDK, you will have a list of APIs that you can use through REST APIs. It's cool. You have like 4,000 APIs at this point, and it's increasing rapidly. And now you can access to the local. Let's change a Python script a bit so that it access to a local one instead of the remote servers. Now after setting up the auth token, let's add another line here called util.url, and this URL is where it points out where you want to lead what you want to call the REST API. So since I have installed the compute Rhino function on the local machine, let's write the local address with the port of 8081, and that's it. I think that this should do it. And if I run this, hopefully I'll get the result faster than before. If I run it and see, like 1 or 2 seconds, it just gives you the result, which is pretty cool. If you run like Unity or Unity, like, which is a game engine, if you want to deal with the real-time geometrical procedural geometry, this is pretty neat. If I open this, I should be able to get the result. And yes. Okay. Cool. Now that's how you can do this. Well, if anybody is interested, I could also make a video in order to use Unity with compute.rhino3d. But for this video, this is it. This is how you can use Python to use a compute.rhino3d service. And there's tons of possibility with this functionality. I hope you find this pretty exciting, since I find it really I am really excited with this function. Even though it's still in work in progress version, it still is a pretty cool one to experiment with. Yeah. Hope you like it. Thank you.